So this might be one of the first or very early examples of tool changing that we have in the industry. I can't stress enough that our goal here is to inspire the next generation of maker, inspire and engage. My name is Steve D'Alessio, and I'm the Executive Director here at the American Precision Museum. I'm here today with Practical Machinist, and we're just getting ready to start our tour. For a moment, we need to step back to the 1830s, 1840s. Products back then were mostly made by hand. We still hadn't had electricity yet. So our first exhibit, our first display here is talking about how products were made by hand. Well, back in the 1840 time frame, countries around the world were looking to expand their territories. So the product that they needed mostly was rifles. So rifles were being made by gunsmiths, mostly by hand. Again, some rudimentary machines. But just as an artist paints the same scene twice, each gun was unique. There was slight differences between each gun, so there wasn't any interchangeable parts. What is important here now to note is that our two founders, Kendall and Lawrence, were busy right across the river from the museum, and they were busy making guns by hand. So our first exhibit talks about made by hand. Along comes around 1846, and a third gentleman comes on the scene. His name is Samuel Robbins, and Samuel Robbins was the money guy. He comes out of Boston. He made a lot of money early in his life, harvesting timber in Maine and through Boston. He approaches Kendall and Lawrence about making 10,000 guns for a government bid. But the key to this bid was the parts had to be interchangeable. So that was the first time that the governments around the world were putting pressure on the armories to create guns with interchangeable parts. So it wouldn't take months and maybe years to get guns repaired. So this panel on this side of the exhibit shows what our compound looked like back then. The buildings to the right of those panels was where the foundries and the workmen's quarters and other workshops were, and they brought materials and product across the river on a bridge into this building that we're standing in. This building is an 1846 armory. It was built specifically to build these 10,000 guns. It was built right on the river, very specifically to generate the water power. So if you take a look at this other panel that we have here, this is the building that we're in, blown up a bit. You'll notice in this corner that there's a wagon in this corner. And during the summer, we filmed the outside of the building to a video called What the Bricks Tell Us. That video is actually on our website if you'd like to see it. But we went around the building and identified through the bricks where doors and windows may have been in the 1800s or so. So with that, we determined that there was a loading dock in this corner of the building, and that helped support our argument that there was there. So anyway, they won the contract for $10.90 a gun. But they had to have interchangeable parts. Well, the idea of interchangeability was not new to this building. What is important to note that these guys added the word precision to the equation. So it was really about precision interchangeable parts. If you have a 2-inch hole and you want to put a 1-inch shaft through it, it'll be interchangeable all day long. But as you tighten up the tolerances, it gets harder and harder to maintain interchangeability. So these three entrepreneurs or innovators, they determined that how to do it was to make things by hand. Sorry, not make by hand, but made by machine. So the first thing they had to do is build our building. And you'll notice that it's all about water. In the basement of this building was an 18-foot diameter breast wheel, water wheel taking water over the dam. It came across the back of the building, then it became along the side of the building, then turned again and powered this large water wheel that was under the building. We do have a kind of a hands-on demo here to be able to show visitors what it was like, or give them the idea of what it was like to be on water power. And then if you look up behind me, you'll see that it's turning a line shaft of belts, and then eventually it gets down to our horizontal mill. So that was one way we started to involve the visitor in this experience here at the American Precision Museum. The next part of this, our three innovators had to really figure out how to build the building, how to make the factory work, how to make it run. So they went around and they really collected the ideas and machines that were going on around this whole area, which was known as the Precision Valley. Went from Windsor, Vermont, where we are today, down to about Hartford, Connecticut. And there was other people figuring out how to do interchangeability, Eli Whitney, Simeon North. But what these guys did is put all that stuff together into a system of manufacture. And this one display case shows a drawing from the 1850s. A couple of things to notice is the spelling of words. Up on top, you'll notice gear is spelled with 2 E's. So that's interesting about it. But the other thing is they did their drawings mostly 1-to-1 or to a scale. They did the drawings and then cut the paper around the drawing. So unlike today, where we use standardized paper, back then it was all different sizes. So our collection includes lots of drawings from that era, and they're all different sizes. This is a lock plate mill. As a machine, it's pretty simple. It's a horizontal mill, again, powered by the line shaft and the belt. But what's important to notice is that this is a form cutter, okay? And this form cutter would be cutting the shape into the lock plate that you see here. It's pretty amazing for 1850 to be able to develop a form cutter with this complexity to it. But this was how you had to do it. You had to move from made by hand, where we used to file to fit things, to letting the machines do it through form cutters at the time. So this is one of our machines here. This one was developed by Frederick Howe. So here's a good video of that machine in action, cutting through the material as a form, and now you have the lock plate. So you have the lock plate became part of the gun, and on that lock plate you mounted the hammer, the trigger, all the firing mechanisms, all the springs, everything that had to go on went on that lock plate. So it was critical that that lock plate assembly fit into the gun stock correctly. So they created another machine called an inletting machine, and the best way to think about it is in light of today. Today we may call it a follow router or a pin router. A stack of plates were stacked up, and each plate had a different pattern in it. A follower would follow a pattern, which would drive a spindle and a cutter and cut a particular pocket on the side of the gun stock. The belt would then be able to be moved from this position up to here, and this is an idling position. Then the operator would take this whole mechanism and turn it and index it to bring in a different follower, a different spindle, to a different set of the pattern to cut a different spot on the gun stock. This machine also had bellows in it to blow out the chips. So this might be one of the first or very early examples of tool changing that we have in the industry. So that was another invention that needed to get put together. The next machine that we have here, this machine was actually invented here in the armory and built here in the armory. It's a rifling machine. If you think of a rifle barrel, it has a long spiral in it to allow the bullet to turn when it comes out of the rifle. Well, the geometry here that you see, when you adjusted it, would determine the lead of the spiral, whether it was a tight lead or a tight spin or a long spin. Again, this machine was water powered and also could be run manually if necessary. It's set up for a short barrel, probably a pistol at this point. On this end of the machine, the cutter would come out and hit this bump stock and increase in depth so that when it cut in the other direction, it would take a little bit more material, and it would go back and forth like that. So again, this machine was invented here and built here, really revolutionized the way we put rifling in a barrel. Our next machine was developed by Thomas Blanchard, and it's the concept of turning irregular shape. If you think about lathes, at the time, lathes were mostly used for turning round shapes or hexagon shapes, but his concept was, can we turn an irregular shaped part? So if you think about it, again, there's patterns. Here they developed a steel pattern for the butt end of the gun. This follower wheel would follow the pattern, which would drive the cutter into the wood stock, and then you'd actually be able to turn this irregular shaped. This was also, concept of a machine was also used a lot on sailing ships. If you remember, an old sailing ship had all these wooden block and tackles all over the ship to control sails and so forth. Those side-mounted wooden parts were done on a machine just like this. So this is early again. The original machine, the first one of this, is down at the Springfield Armory in Springfield, Massachusetts, on display. They also developed a multi-spindle drill press, 6 spindles. You would adjust each spindle from the top and then press on a pedal or pull a handle, and the table would go up, and you'd be able to move the part from station to station or put one big part in and do 6 things at one time. So fast forward to 1851. 1851 is the Great Exhibition at the Crystal Palace in London. Our innovators were invited to go there to show what they could do. They put their parts on the table, and the Brits were able to interchange all the parts and build all the different guns. They were so amazed that they coined the phrase, the American system of manufacture. And that's really this is really the birthplace of that system. This drill press you see here, I came across in our collection an invoice from around 1859, 58, and it was about $253 at that time. So it was a lot of money. But most important to think about is the Brits then placed another order for 10,000 guns. However, what they really wanted was the machines. So right in this building, we started to manufacture machines now. So this could be one of the early places where the machine tool industry was born. So that's really important to note. It wasn't always about the guns, it was about the process. So in this case line that we have here are guns that were all manufactured here right here in this building. The bottom 2 are probably the most common ones. As we talked about, made by hand. This is the original of the 1841 that the replica is in that other display. The bottom rifle is an Enfield rifle, and that was the one that was built for the British and exported there. They also manufactured some interesting pistols here as well, the pepper box. This case line shows just some guns that were manufactured in the area. Something happens right after this period of time. Robbins and Lawrence Kendall was bought out earlier, but Robbins and Lawrence goes under. They expanded into lots of different things, and just overexpansion really hurt them. So they wound up closing, and Lawrence winds up down at the Sharps factory, bringing the American system to another place. So this place was really, this armory was really an incubator that allowed people to learn a craft, learn a skill, and then migrate down the Connecticut River to where Colt and Remington and those guys started to form. So the next piece of our tour here, we'll talk about some other machines now. So let's think about all the machines we've just saw create chips. And now these 2 machines create shavings, like a wood shaving with a plane. They're called planers. This one is 1825. And if you can imagine what it would be like in the 1800s to have to crank this handle back and forth to scrape material or shave material all day long. I want to point out that if you look at the machine, it's quite square and kind of very parochial looking. There isn't a lot of design into the handles and so forth. The next machine is 1845 now, 1850, and now you notice same function, does the same thing, but now it is a certain element of design added to this equation. You now start seeing castings with bird features, other features up here, handles start to get different kinds of style to them. So there's a couple theories. One is that patterns at the time were made by carpenters, and the manufacturer of the machine tools were allowing the carpenters to put their own touch on it. The other concept is that it's starting to become the Victorian age of design, and maybe that was creeping into the machine tool industry as well. So a couple theories. We don't know for sure, but there's a couple theories. So last year, we joined a group called the Vermont Curators Group, and they asked us to highlight a technology. Well, we looked around our museum and said, you know, we really don't talk enough about measurement and metrology. So we brought out a lot of things from our collection to talk about that. The first is a ballistic chronograph that talks about measuring of speed. You'd wind up with a couple bars that would drop. This key would allow 2 bars to drop at the same time. And when the smaller bar landed in this brass cup, it would hit a little chisel that would put a mark on this copper bar. We'd put it all back together again, and we'd set up 2 screens a certain distance apart. When the bullet broke the first screen, it released 1 bar. When it broke through the second screen, it released the second bar. That second bar again would come in and hit with a chisel on the copper bar that had already started falling. So now you have distance and gravity, acceleration of gravity and distance, and now you were able to figure out time. So the next thing we brought out is some voltmeters and amp meters. We measure power in our lives every day. What is interesting is this meter here came out of our collection with its glass all shattered, as well as missing a knob. I only bring that out because we cleaned out all the glass and then went to a coordinate measuring machine, which is today's technology, and probed the whole shape. We then took that file and we took it to a laser and had a plexiglass piece cut at it from the laser, dropped it back into the artifact, and then remade a knob on a conventional lathe. So part of our mission here is not only to show off things, but it's also to preserve and to restore objects in our collection as well. The next part we do is we measure time. There's an 8-day clock here. We're not 100% sure why 8 days, but we think they just didn't want the clock to run out on the 7th day. So the first artifact we have back here is an 1878 Super Mic from Brown & Sharp. It came out of their lab. We did check it about 10 years ago, and it was still capable of measuring down around 10 millionths or so. So it was pretty accurate. All kinds of micrometers and height and different drop gauges and so forth. We have a simple machine here. It's a simple measuring device, a protractor, which everybody has probably used at one time or another. It's made by Brown & Sharp. So the real question is a little bit of a spline along here, and the real question is how did they put it together? How did they get it together so it wouldn't come apart? So our theory is that this shape in here acts as a spring. They compressed it, slid it together, and then released it. One of the fun things we do here at the museum is to study the object to kind of figure out what it was used for, how it was made, why it was made, what its purpose was in industry. We have metal hardness, another thing we see in our lives every day. We have a scleroscope, which is a ball drop hardness tester. You pump up a ball, release it onto the material. How high it bounces determines how hard the material is. Golf ball, you drop it in sand, it goes thud and it just stays there. You drop it on a sidewalk or concrete and the ball bounces higher. Same principle there. The next one is a Rockwell tester. It hasn't changed in all these years. This one's back from the 1930s. It's still about a weight dropping and penetration. Today's ones, of course, are more electronic driven, but the principle is the same. A lot of shops have them. So fast forward again, the Vermont Curators Group came to us and asked us to use a technology that changed our lives last year. So we brought out temperature meters for everybody that was going through the pandemic. All of these are different eras of temperature meters. This is all temperature meters and gauges from our collection. I'll just come back this way just a little bit to our set of gauge blocks that you see here. Most people in our industry know it as Joe blocks or Johansson blocks. Johansson was a Swede. Henry Ford bought his company and started making gauge blocks by Ford. This particular set, however, has some history to it. Henry Ford really liked Thomas Edison, and he gave him this set. And this set of Joe blocks came out of Edison's labs, and actually Edison's signature is on the back side of this case as well. So it's a true artifact. Those of you that are in the industry, I know I've been in the industry a long time, gauge block sets are only complete on the first day that you get them. Within 2 or 3 days, there's always one missing. This is the first time I ever saw such a pristine set and complete set. There's a surveyor's transit and a sextant. They're in the case lines here because they're about measurement, but really their purpose is to show what craftsmanship and workmanship looked like in the early 1900s. These machine parts are all done by hand, and they're really very, very nice. I'll take you back to this planer again, into this vertical shaper that's there. Again, you see the fluted columns, which starts to come in. You start seeing a drill press like this, again, with more style to the castings. And then you look at this shaper, and now you see more Art Deco and Gothic design into the casting. So it looks like there has been some kind of influence on the machine tools at the time. This machine, again, was developed by Frederick Howe. It's a universal milling machine, or we call it an indexing machine. There is this index plate here, and as you move that, it would turn the vise into different directions. Removing the drift pin from here, you could take the vise out, put a chuck on, or put another center on it, and you can do lots of different things and make lots of different shapes and parts as we went along. 1861, turret lathes, all the big deal. Turret lathes, as you know, have a single turret, maybe like you would see on a castle or a tank. But note, and we'll talk about it a little bit further along, it's still one tool on one spindle, right? So you still would have to move the handle back and index all these tools, but you still only would get one part off of the spindle. We know Brown and Sharp, mostly for measurement. That's probably what they were big for, but early in the 1860s, they were also manufacturing machine tools as well, and that's a milling machine. On this side, we have a threading machine. Stock would be put in here. They would move this along the stock to thread it, reverse it, and then bring it back out again. So this was another machine that was designed and built here in the building. Well, at some point in time, gun manufacturing is no longer needed. So what do you do with your factory? You now have to convert factory to consumer culture and to consumer products, but you now have all of that information and all of that skill that was developed early on to the American system of manufacture. We're able to manufacture precision, interchangeable parts.